Hello friends, I welcome you all for the online course on non-conventional machining. Today we are going to cover laser beam machining. In this lecture we are going to see introduction about laser beam machining, then working principle of LBM, different equipments used for LBM, then different process parameters, and at last advantages, disadvantages and applications of laser beam machining. Let us move for introduction of laser beam machining. Laser beam machining is a non-traditional subtractive manufacturing process, and it is a form of machining in which a laser is directed towards the workpiece for machining purpose. This process uses thermal energy to remove the material from the metallic or non-metallic surfaces. In LBM, a laser is used on the surface to be worked, and the thermal energy of the laser is transferred to the surface, which heated and melting or vaporizes the material. Laser beam machining is best suited for brittle materials with low conductivity but can be used on most materials. This is about the LBM. Here I will highlight some applications of this laser beam machining. Here I have given the two column. One side is application and which kind of laser we can use for that application. So first category is the cutting. For metal, plastic, ceramic, we have the different types of the laser. Then again for the application of the drilling, again in that if you drill the metal, then plastic, we can use a different laser type. Again for marking application, you can use laser. For surface treatment, again welding and metals, we can use different types of laser for the laser beam machining. Let us move for the working of this laser beam machining. In this figure I have shown the schematic diagram of this laser beam machining. So through this image you will get the working principle. In laser beam machining, laser beam is focused on the workpiece material to remove the unwanted material, okay, from that workpiece. How that material will remove? Using the thermal energy which hit that work material, and due to the vaporization you will get the unwanted material. In the laser beam machining, the material removal rate much must depend on the wavelength which is used in the laser machining. So I have shown the bunch of lights, or we can say light beam, okay, which will focus on the workpiece. So this is a working principle of laser beam machining. Now which kind of work material we can machine using this LBM? So metals with the high hardness and strength we can machine through this LBM. Again soft metals, ceramics, glass and glass epoxy, plastics, rubber, cloth and wood also we can machine using this LBM. Now for laser beam machining we require the laser. So again we have the different types of the lasers. Let us see one by one. So first is the gas lasers. It is a electric current is liberated from a gas to generate a consistent light. Some of the most commonly used gases consist of HNE, R, and CO2. Fundamentally, these gases acts as a pumping medium to ensure that necessary population inversion is attained. So this is about the gas lasers. Second is the solid state laser. They are designed by doping a rare element into various host materials. Unlike in gas lasers, solid state lasers are pumped optically by flash lamp or arc lamp. Ruby is one of the frequently used host material in this type of laser. A Lubin laser is a type of the solid state laser whose laser medium is a synthetic ruby crystal. These ruby lasers generate deep red light pulses of a millisecond pulse length and a wavelength about 694.3 nanometer. The synthetic ruby rod is optically pumped using a xenon flash tube before it is used as an active laser medium. So this is about solid state laser. Now third laser is examiner laser. The state is different than in solid state or gas laser. The device utilizes a combination of reactive and inert gases to produce a beam. This machine is sometimes known as a ultraviolet chemical laser. This is about the lasers. Here I have shown some characteristics about the lasers. So for a different application, type of laser we can use different. So one column I have given large applications, and in second column types of laser. So large hole up to 1.5 mm diameter you can use ruby or ND glass or NDR laser. Large hole, again we have the different laser for small hole drilling. So here I have given the select how we can select the laser depends the characteristics. Now we'll see the construction of these lasers. So first I will discuss the CO2 laser. So here I have shown the figure about the CO2 laser. So gas lasers can be axial flow as I have shown in the figure, transverse flow and folded axial flow also. The power of this CO2 laser is a typically ground around 100 watt per meter of the tube length. Thus, to make a large power laser, rather long tube is required, which is quite inconvenient. For optimal use of floor phase, high powered CO2 lasers are made of folded design. Second, it is the solid state laser. Again, in this diagram I have shown the construction about this solid state laser. The flash tube is operated in pulse mode by charging and discharging of the capacitor. Thus the pulse on the time is decided by the resistance on the flash tube side, and pulse of time is decided by the charging resistance. There is also high voltage switching supply for initiation of the pulses. Now NDR laser. So here again I have shown in the figure laser. This is pumped using the flash tube. Flash tube can be helical. They can be flat also. Typical the lasing material is at the focal plane of the flash tube. Though helical flash tubes provide better pumping, they are difficult to maintain. So through this figure I have shown some parts about this laser. Now here I will discuss the cutting depth of this laser. So cutting depth of this laser is directly proportional to the quotient obtained by dividing the power of the laser beam by the product of the cutting velocity and the diameter of the laser beam slot. So here I have given some mathematical formula. So in this, small t is the depth of cut, then capital P is the laser beam power, small v is the cutting velocity, and small d is the laser beam spot diameter. So the depth of the cut is also influenced by the work material. Okay, the material's reflectivity, density, specific heat, and melting point temperature all contribute to the laser ability to cut the workpiece. Now we'll see the process of this laser beam machining. So in the process, the negatively charged electrons are rotates around the positively charged nucleus in the specific orbital path only. Based on the variety parameters like atoms, electrons, electron structure, plus the presence of the electromagnetic field, the radii and the geometry of the orbital path are changed. The energy of the orbital must be related to the single energy level only. At the zero level condition, the atom is considered at the ground level. This is because of all the electrons occupy the lower potential energy. From the external sources, the ground level electrons absorb some energy to stimulate high stage. At the elevated temperature, the electronic vibrations are increased, and in chemical reactions, they absorb energy from the protons, which are external sources. The electrons are moving from the lower to higher level energy. And when the electron reaches the high energy level, at the instant we observe the unstable band of the energy. By releasing the protons within a short time, it reaches the ground level. So the process is known as spontaneous emission. The existing proton and the emitted photon have the same frequency. In same condition, the energy state changes the position of the electron into the metastable energy band. In a material, if the electrons are pumped to the higher metastable state and are compared to the atom present in the ground state, where the phenomena is known as proportion inversion. So this is about the process. Now I will discuss the some advantages. Since the rays of the laser beam are monochromatic and parallel, it can be focused to a very small diameter and can produce a energy as high as 100 megawatt or energy for a square millimeter of area. It is essentially especially suited to making accurately placed holes. Again, laser beam machining has the ability to engrow or cut nearly all materials where traditional cutting methods may fall short. The cost of maintaining lasers is mandatorily low due to the low rate of the wear and tear. The machining provided by the laser beam is high precise, and most of these processes do not require additional finishing. Laser beam can be paired with gases to help the cutting process, okay, for more efficient. Also help to minimize oxidation of the surface or to keep the workpiece surface free from the melted or vaporized materials. These are the advantages. There are again some disadvantages are there. The initial cost of acquiring a laser beam is moderately high. There are many accessories that aid in the machining process. Handling and maintaining of the machining require highly trained individuals. Laser beam machining consume a lot of energy. Deep cuts are difficult with the workpiece with high melting points and usually cause a taper. Now we'll discuss some applications about the laser beam machining. Lasers can be used for melting, cladding, marking, surface treatment, drilling, and cutting among other manufacturing processes. It is used in the automobile, shipbuilding, aerospace, steel, electronic, and medical industries for precise machining of the complex part. Laser cladding is used to coat cheap or weak parts with a harder material in order to improve the surface quality. Drilling and cutting with laser is advantageous in that there is a little to no wear on the cutting tool, as there is no contact to cause damage. Milling with the laser is a three-dimensional process that requires two lasers but drastically cut cost of machining part. Laser can be used to change the surface properties of the workpiece. Laser beam machining can also be used in conjunction with the traditional machining methods. By focusing the laser ahead of the cutting tool, the material to be cut will be softened and made easier to remove and reduce cost of production. So this is about the laser beam machining. Thank you very much.